Okay, which ordered pair is a solution to y equals x and x squared minus 2? So here, right, we want to set this up algebraically or graphically, it doesn't really matter. Whatever we end up doing, we want to find when do these two functions meet. So I'm going to actually set up so y equals x, okay, and then y equals x squared minus 2. So here, at some point, x is going to equal x squared minus 2. They're going to cross. If I subtract x, I can quickly solve this because this cancels out to 0, and we have x squared minus x minus 2. You can now factor this. When you are solving this, you're solving when they meet. So x and x, what factors of negative 2 add up to negative 1? Well, negative 2 times positive 1 is negative 2, and if we add them, we get negative 1, so that's the answer. But here, x minus 2 equals 0 and or x plus 1 equals 0, right? So the idea is when two things multiply, these two things, to get 0, one or the other or both are 0. So x is 2 here and x is negative 1 there. You just solve for x. So these 2 points are these are the two x values of where the two lines meet. Plug them into your line. This is a really nice one to use, y equals x, and you find the answer. They meet at 2, where y and x are equal, and they meet at negative 1, negative 1. They're going to give us one of those points here, and they give us 0, 0, right? Sorry, what am I? 2, 2 is the answer, right? So let's move on. What is the value of the y-coordinate of the solution to the system x minus 2y equals 1 and x plus 4y equals 7? Two lines are going to meet once, so we want to find when they meet. Equals 7. If we subtract these two equations, watch how nice this is now. X minus x is 0. Negative 2y minus 4y is negative 6y. And 1 minus 7 is negative 6, right? So then if we solve for y here, y is going to equal what? Well, divide both sides by negative 6. And y is equal to, oh boy, this pen's not working. Try to fix it. Okay. So y equals, divide both sides by negative 6, and y equals positive 1. So that's the answer. They meet at a point where y is 1. Choice number 1. Okay, so here we want to graph this line and this other line and find when they meet. So here, what I'm going to do is, the second line, we have a slope of negative 2 and a y-intercept of negative 1. So that means at negative 1 is our y-intercept, then we go down 2 over 1, right? Or up 2 back 1. This is our slope. Draw the line to connect it. Oops, wrong spot. Right, this will do it. Okay. So here is the the second line they give us. Y is equal to negative 2x, right? Minus 1. The second line, they don't give us an mx plus b format, but I'm going to rewrite it. That's how I like to solve these. So I'm going to add 2y to the right and subtract 10 to the left. So 4x minus 10 equals 2y. But I don't know what 1y is, so divide everything by 2. Y equals 2x minus 5. Sorry, this pen's not working very well. 2x minus 5. And that tells us everything we need to know because now the y-intercept is at negative 5. And the slope is 2, so it goes up 2 over 1, up 2 over 1. And you could see that they're going to cross at 1, negative 3. So that's the answer. And you can plug in 1 for x to check. If you plug in 1 for x in both of them, y would be equal to negative 3, and that's the answer. So you just want to label this. So with these, you just graph the lines and find when they meet. And if that doesn't help you, you can use the calculator, graph them, and then hit second trace and you'll find they intersect. Okay, solve the following systems algebraically. So they give you these two linear equations, 3x plus 2y equals 4, and then 4x plus 3y equals 7. So I think the easiest way to solve this is look at your coefficients 3 and 4 and 2 and 3, and then multiply one of the equations, or both, so that those two coefficients are equal. So 3 and 4 are not equal, but if you multiply the first equation by 4, and the second one by 3, they will be equal, and this helps us tremendously. Watch what happens. We get 12x plus 8y equals 16. Multiplied everything in the first by 4. Now multiply everything in the second by 3. We get 12x right, plus 9y equals 21. So now, because these x values are equal, if we subtract the second equation from the first, they cancel out, and we get 8 minus 9 is negative y, 16 minus 21 is negative 5. So then y equals 5, and we can plug that in to find x. So we know 3x plus 2y, so 2 times 5, equals 4. So 3x plus 10 equals 4. Subtract 10 from both sides, we get 3x equals negative 6 divided by 3, and x equals negative 2. So our solution, the point where they meet, is negative 2, 5. Okay, what is the y value to this solution to the system? X plus 2y equals 9, and then x minus y equals 3. Well, since the x's are equal here, I'm going to cancel them out by subtracting. X minus x is 0, 2y minus negative y is 3y, and 9 minus 3 is 6. Divide both sides by 3, and y equals 2. So they want to know what the y value is, and that's it. It's 2. Okay, Julie went to the movies and bought 1 jumbo popcorn, so 1 jumbo, plus 2 chocolate chips for $5. Marvin went and bought 1 jumbo and 4 chocolate chip cookies for $6. How much does 1 chocolate chip cookie cost? Well, it might be obvious to you. You can probably see the answer by thinking about the change in cost, and only the cookies change. So they must be 50 cents each, right? Because you bought 2 more cookies and the price went up by $1. But you can solve it algebraically because a lot of these are tougher than this. What you do is set the system like we did here and subtract one from the other if they cancel out. So j and j subtract is 0. 2 minus 4 is negative 2, negative 2c. 5 minus 6 is negative 1. Negative 2c equals negative 1. How do you solve? Well, divide both sides by negative 2, and c equals 1/2, or 50 cents, which is our answer here. What is the solution to the system? 2x minus 5y equals 11, and negative 2x plus 3y equals negative 9. Okay, sorry about this 3 right here. Alright, since these are opposites, we're going to add them. We want to cancel out. These cancel out. Negative 5 plus 3y is 2y. 11 plus negative 9 is 2. Divide both sides by 2, and y equals 1. So out of these choices, you would normally plug y back in to one of the equations to solve for x. But the only one where y equals 1 is choice 4. So that must be the answer. Okay, Joe and May work at a concession stand. They each earn $8 per hour. So Josh and May. So Josh worked 3 more hours than May. So Josh's hours are 3 plus m. So whatever May worked plus 3. That's what Josh's hours are. If Josh and May earned a total of 120, so Josh plus May equals 120, how many hours did Josh work? Well, since you have these two equations, probably the easiest way is to substitute this into this right here. So instead of j plus m, 3 plus m equals 120. So now you have one variable, 3 plus 2m equals 120, and we're almost done. Let's solve for m. So 3 plus 2m equals 120. Subtract 3 from both sides. 2m equals 117. But I feel like I did something wrong because you can't divide 117 by 2. Right? So let's backtrack. Joe and May work at a concession stand. They each earn $8 per hour. Oh, that's the mistake. So Josh worked 3 more hours than May, right? So whatever May worked, the amount of hours, you add that plus 3 and get Josh. But here, it's not j plus m equals 120. It's 8j plus 8m because they each earn $8 per hour. So it's not that the j plus m would be their hours adding to 120, but they didn't work 120 hours, but the money they made was 120. So it's 8j plus 8m. So that means 8 times 3 plus m plus 8 times m. We're just substituting still. What does that do? Well, that just changes the work here a little bit. So 8 times 3 plus m is 24 plus 8m, distribute, plus another 8m equals 120. This is 16m. And then let's subtract 24 from 120. We get 96. And in case you're wondering, right, 96 divided by 16, right? That's 6. So what does that mean? Well, May works 6 hours. So, and Josh worked 3 more than that, so Josh worked 9 hours, choice 2. And you can check that to see if it works. Which ordered pair is a solution to the system's x plus 3, y equals x plus 3, okay, and y equals x squared minus x. Well, at some point, if they have a common solution, they'll be equal to each other. So x plus 3 will equal x squared minus x. And we can solve that here. This is probably the quickest way to do it. What you would do is subtract x, subtract 3, and bring that all to one side. So in these problems, you get a pretty common trend is to bring everything to one side. This is 0. X squared minus 2x now, minus 3. Now we factor. Alright, well, we're going to have x's here. What factors of negative 3 add to negative 2? Well, we're going to have negative 3 and positive 1. They multiply to negative 3 and add to negative 2. So now if this is true, then x minus 3, if that equals 0, x equals 3. And if x plus 1 equals 0, then x equals negative 1. So our 2 points have to have 3 and negative 1 for your x values. So far choice 1 and choice 4 are out. Let's plug in, so it could be choice 3 or 2. They're not going to even give us negative 1 here as an option. So let's work with what they give us. In both these points, x is 3. So plug 3 into either formula. Use the linear formula, it's much simpler. So y equals x plus 3. And if x is 3, plug that in, y equals 3 plus 3 or 6. So the point is 3, 6. Choice 2. Okay. What's the solution to the system? Well, that means where do the lines cross? That's right. That's a nice, easy question. 1, 2, 3, 4, then up 2. The answer is 4, 2. Anytime they ask you for a solution to the system or what order of pairs is the solution, they're asking you when do the functions or lines cross. Okay, which point is a solution to this system? Well, here, again, when 2 lines cross, they're a solution. So these are the 2 solutions. You have negative 2, 2, and this point, which is 2, 4, 6, 8, and then up 9. So the answer is 1, 8, 9. Okay. Alright, so where do these 2 lines meet? That's basically what we're graphing. They're saying, what's the solution? So y equals 4x minus 1. Well, that just means negative 1 is your y-intercept, and your slope is 4. So up 4, right, over 1. Up 4, over 1. And then we can go back, down 4, back 1. So we have this first line, relatively easy to graph, right? Okay, and then label it y equals 4x minus 1. Usually you label on the line as well. And then here, I'm just going to rewrite it slightly. Subtract 2x to get on the right side. We get y equals 5 minus 2x. This enables me to quickly find the y-intercept and the slope. So here, pen's not working very well. We have 5 minus 2x. That means that your y-intercept is 5, right? And so 1, 2, 3, 4, 5. And the slope is negative 2, so it's down 2 over 1 and so forth. But here it's nice, they give you a really straightforward problem. They cross right here. So label this one 2x plus y equals 5, or you could label it the way we wrote it. And the answer is right here, 1, 3. These 2 lines cross at 1, 3. Okay, which coordinate represents a point in the solution set to the system of inequalities below? So y has to be less than or equal to 1/2 x plus 13. So that, I'm going to use a graphing calculator on this one. So here, right, we clear this off. So it's 0.5x plus 13. What's nice is if you scroll all the way to the left here, y has to be less than this equation right here. So this blinking symbol right here is a line. We want to get the less than region. So it's the lower triangle. Then it can graph that. I'm going to clear this off here. I'm going to go back to this real quick and rewrite it. So here I'm going to subtract 4x and divide by 2. What that does is I get 2y is greater than 3 minus 4x. If I divide by 2, I get y is greater than 3 minus 2x. This will help me enter it into the calculator and think about it myself. So y is equal to 3 minus 2x. Scroll all the way to the left. And this time y is greater than, so we want to scroll through until we get the upper region. Lower region, upper region, where is it? Okay, I must have missed it. Try again. Sorry. There it is. Okay, we graph the 2. So it gets you this, sometimes the zoom's a little bit off. Let's just reset zoom, standard. All right, so I'm going to zoom up a little bit. So zoom in. Go to scroll up because I can't really see the regions very well. It looks like they're crossing way above here. Sorry, scrolling up. There's a little lag in these calculator programs here. Enter. A little bit better. I don't like it. Sorry. Let's go to zoom standard again. Okay. So you can kind of see that this region is where they cross, right? So anything in the first quadrant seems like it's going to work. 1, -4 doesn't seem like a very good candidate. Well, sorry, -4, 1 is definitely, it's over here somewhere. You can just scroll through to kind of see what's happening. It's definitely not the answer. -2, 2, right, is also, you can kind of see on the graphing calculator, it's not going to work. So our choices are 1, 4, and 2, -2. Let's find where 2 is here. You scroll through it, see how the x value changes. So 2 is about here, right? So -2 is not the answer, right? You can see that 2, -2 is outside the region. It's kind of blinking in this one region. It's where the crisscross region is. That's the common solution. So 1, -4, if you scroll over as well, it's also not in the solution set. Let me go back. Oh, that's my mistake. So here, back to this point, I divided both sides by 2. It's not 3 minus 2x, it's 1.5. Sorry. Right, we divide both sides by 2, so 3 divided by 2 is 1.5. Okay, well, this happens, I mean, mistakes happen, right? So here, sorry about that, 1.5 minus 2x. Okay, hopefully that'll make it a lot easier. Alright, so that changes a little bit. So here, the -4, 1 and -2, 2 is still out of it, but I think you can see that 2, this time -2, right? And you can see it barely, it's -2.2, it's still in the region. So here we could go to zoom and zoom in and really verify it, but that'll work as well. Now, so the answer is 2, -2. Let's say this is happening to you on the graphing calculator, you can't figure it out. Plug in 2 for x into both of these, and plug in -2 for y. And you know this is the answer to both of them because it's the only point that when you plug in 2 and -2 for x and y, that the inequality is actually true. Like the left-hand side in this case will be greater than 3. Plug in all the other points and you'll find that when you plug in x and y, you get untrue inequalities. That's another way of doing it if my graphing demo there just really confused you. So they want us to solve for this system algebraically. So wonderful. We subtract the second from the first because the x's cancel out, and 2y minus y, that's color, you can't see that, 2y minus -y, so we add y there, it's 3y. 9 minus 3 is 6, so y is equal to 2. What does x equal? Well, 2x plus 2y is 9, so 2 times 2 is 9. So 2x plus 4 equals 9, subtract 4 from both sides, and 2x equals 5, so x equals 2.5. So the answer would be 2.52, right? That's the point that solves both. Okay, thank you.